Hello everyone, good day. Welcome to VSPARKZ. Today we are going to see the concepts of Kubernetes Namespace. We are also going to see a demo on the same as well. If you like this video, please subscribe to VSPARKZ channel and click the bell icon for the latest updates. This is the agenda of this video. We are going to discuss on these topics in this video. What is Kubernetes Namespace? Namespaces provides a mechanism for isolating group of resources within a single cluster. This logical isolation is very useful when different teams share a single Kubernetes cluster. Let us consider this example. Suppose say we have a cluster which should be used for development, testing and production. Deploying all these three environment resources in a single cluster makes the life in Kubernetes so complex. Just like this. In order to mitigate this problem, Kubernetes provides a solution called Namespace. With the help of Kubernetes Namespace, we can logically isolate these three environments, that is development, testing and production, just like this. All these three environments are sharing the same underlying physical cluster. Each of these namespaces are logically separated from each other, but it has the ability to communicate with each other. Why and when to use Kubernetes namespace? Environment isolation. Within an organization, large teams can use namespaces to isolate their applications and microservices from each other. Teams can reuse same resource names in different namespaces without an issue. Access control. Enhanced role-based access control is possible with the help of namespaces by limiting users and processes to certain namespaces. Performance. Using namespaces, the performance of a given cluster can be improved. If a cluster is separated into multiple namespaces for different projects, the Kubernetes API server will have fewer items to search when performing operations. This ideally improves the performance of the cluster. Not all the objects are within the namespace. Almost all the high-level Kubernetes objects like pods, deployments, daemon sets, jobs are bound to some namespaces. This means that they all are created within the scope of a namespace. Whereas there are some other low-level components like storage volumes, nodes, cluster roles, and so on. They are created on the cluster level, meaning these resources are common to all the namespaces. Default namespaces. Kubernetes comes up with these default namespaces. First one is the default one. As the name implies, this is the namespace that is referenced by default for every Kubernetes command. Until a new namespace is created, all the objects and deployments resides within the default namespace. Second is the kube system namespace. All the Kubernetes cluster components like API server, controller manager, kube proxy, DNS are deployed into this namespace. Ideally, this namespace should not be used for our application deployments. Third is the kube public namespace. This kube public namespace is also not recommended for usage as the resources deployed into this namespace is fully public and it can be readable by all the clients without authentication. Fourth one is the kube node least namespace. This namespace holds the least objects associated with each and every node. This node lease allows the kubelet to send heartbeats to the control plane to detect node failures. How can the pods communicate across Kubernetes namespaces? Suppose say we have a cluster with two custom namespaces called the front end and the back end. In the front-end namespace, we have a web server pod and a DB service pointing to the MySQL database pod. Similarly, in the back-end namespace, we have a DB service pointing to MySQL database pod. When the web server wants to reach to the database of the same namespace, it can simply refer to the DB service name, just like this. Whereas if it needs to reach to a database of different namespace, it has to refer the connection just like this. That is service name dot namespace dot svc dot cluster dot local. This is how the pods from one namespace can communicate to the services of the another namespace. Now let us see a demo on how to create namespaces and to deploy resources in the namespace. Step 1. Access and inspect Kubernetes cluster. Access the Kubernetes cluster using kubectl utility and check if the Kubernetes cluster is running properly. Just to save the time, we have consolidated all the commands in a notepad and the same is available in the video description. This is the master node where we have connected to the Kubernetes cluster. Kubectl cluster info command gives the details of your cluster. Now check the nodes and pods. Our cluster is running with one master and two worker nodes, but worker node number 2 is down and that's why it is showing as not ready. Now check the pods in the kube system namespace. Yeah, you can see all the cluster components are running properly. Step number 2, inspect the default namespaces. By default, all these namespaces will be present and it was created by the Kubernetes cluster itself. Yeah, you can see all the default namespaces. Instead of typing it as namespace, you can also use a short notation for namespace as ns. Both the commands will give the same results. Step number 3, create development and production namespace. Yeah, you can see the development and production namespaces are now created. Step number 4, deploy and inspect pods in the development namespace. We are going to run an Nginx pod named Nginx in the development namespace. For this step, we are going to run this simple command to create a pod. Now the pod is created and you can check the same as well. We can also use -n as the short form for namespace indication. If you do not mention any namespace details, Kubernetes will display the results for the default namespace. Step number 5, deploy and inspect the pods in the production namespace. Since our worker node number 2 is down, all the pods are getting deployed in the worker node number 1. Now for this step, instead of running commands to create a pod, we will create a YAML manifest for deploying pods. Now this command will give you the YAML skeleton for creating a pod. Redirect this output to a file and remove the unwanted lines. If you don't know how to create and modify this manifest files for the Kubernetes objects, please refer to the previous videos. Now the YAML file is updated. Apply this file into the Kubernetes cluster. Now the Nginx pod is running in the production namespace. Check the same in the development namespace. As we can see, both the pods are running with the same name in different namespace. This proves the logical isolation of resources using namespaces are working. Well, that's it for this lecture. This is the summary that we have discussed so far in this video. Thank you from VSPARKZ and thank you for watching this video.